Hi everyone, I'm Sapna. I lead product at Maxim, and today in this cookbook for you product managers, we are going to deep dive a little into the prompt engineering piece of AI development. So when we talk about prompt engineering, we want to make sure that as product owners, we are able to iterate on this piece that actually defines what our user experience looks like. And today we're going to take a sample agent and look at how we can manage our prompts, version them, create templates, and run some of these experiments as we continue to iterate and learn. Here on my screen is the Maxim UI, and I'm going to go ahead and jump directly into the prompt section where we can start with our demo agent. Here I've created a demo coding agent that we are going to be using for the purpose of this cookbook. I've already written out a quick prompt so that we can get started as soon as possible. And I'm going to quickly paste it here as my system message and then walk you through the other configurations on this page. So here you can see on the system message, within this prompt, I have multiple sets of instructions. The beginning starts with what kind of job this agent needs to do, how they should do it, and then there are two use cases, one for writing new code in terms of what kind of files they should create and things like that, and second for improving existing code, how do they manage the diff. And the last part you can see is this useful to know information, which is a set of instructions that it should always follow, or a set of rules that we want in terms of the code creation. So this is what our prompt looks like. You can see right now we're on the GPT-4o model. I have access based on whatever model I want to use if I want to test it for different providers. And I can also set configurations and test it with different sets of configurations. So for example, here you can see that, let me just increase my max tokens a bit on GPT-4o and try to run this for a simple use case. So maybe generate a JavaScript function for hex code selection at random, and let me now run this. Now this is exactly what your actual user would be doing, and you want to test how well your prompt works. And what is happening here is we're going to hit this particular model and get you your assistant response, which is actually in this case you can see that it has created some code. You can look at what that is, what are the different files, etc. You can now iterate on your prompt. Now where this becomes truly helpful is to be able to compare this for different models, compare this for different prompt configurations. So let me quickly save this session and then create a new prompt to compare. In this case, I'm just going to create a sample prompt within this experience itself because I don't want to save it till I'm sure. You can see all of this is pre-filled, and maybe I just want to test this on GPT-5 that I have here. Right now, I'm not changing anything on the configurations, and I can run this. So what is happening here is that we are comparing how GPT-4 and GPT-5 would respond for the same user message. You can see GPT-4 of course was much faster. There's a detailed response from the assistant with some code generated, etc. And you can see that the tokens, cost, latency are also provided here. GPT-5 being a much slower model is still responding, so we'll wait for that to happen and see how the response might be different. So here we have the response finally from GPT-5, but it's much more detailed. It talks about the architecture it has created. It also has divided its files very differently. It's a much longer response, and we can actually analyze how it's different in GPT-4o and 5, what is more helpful, but you can see the latency is much higher as well. For now, maybe I decide that this is good enough for me and I actually want to optimize for latency and then over time look at things, because this is also much more costly. So I'm just going to go and remove this one and maybe just discard these changes, and instead For GPT-4, I will publish this version. I'll say this is a GPT-4 MVP prompt, which is the first thing I'm going to kind of test with, and publish this version. Now here I have my first version of my prompt. Over time I can create more versions, view my versions, compare diffs between them, etc. But for now, we're going to quickly move to how can we structure this prompt in a more helpful manner. You can see that there are certain instructions here that are common to all my coding agents around what instructions I'd give it, how it should write the answer, etc. And these two lines I want to create into a template that will always be reused, and nobody goes and touches these because I know they work well. So what I'm going to go ahead and do is copy this and move to the prompt partial section here in my library, and create a new prompt partial. In the interest of time, I've already created a folder for these partials that I'm going to use in this demo. I'll just create one quickly for this use case so that we are clear how this works. So I'm going to call this general instructions, put it into this folder and create this partial. And I can actually just paste this instructions here. Right now it's just 2 lines. This could be as detailed as you want, and you could have RBAC to say that certain roles only could edit these. And I'm going to publish a version of this partial as well. All versioning is possible within partials, just like we were talking about prompts. I'm just going to call this initial version and create it. Now you can see that I can use this partial within the prompt or inside an evaluator using partials.xyz and the version that I want to use. Now what I'm going to do is go to the prompt, go to this coding agent, remove this from here, and instead reference a partial, where here you can see it is use prompt partial, where this partial would be the one I just used, general instructions and latest version, because maybe if I change versions I always wanted to use the latest. And now this has been referenced as a partial instead of a static content. Let me just quickly save this session, and I can do the same thing for my last, this is the assistant message. Let me just quickly remove this. I could do this for my system message instructions as well, the ones we have here. In place of this, I could actually say the useful to know should be use the prompt partial, which is global rules, and that is latest, and then use that one. So here you can see that I have divided both of these into partials, and my partials are referenced as variables. You can check what the partial actually says. You could render the preview and see the actual content. This helps you manage these templates and manage your partials much better. So there could be certain cases where you want your partial to render based on some condition. For example, in this particular case, we have 2 different modes, a generate mode and an improve mode. If somebody is trying to generate code, the instructions are very different from if they are trying to improve code. And that's where we would want this to become conditional. All of what we have right now is specifically just for generation, but we want to use the same prompt for both cases. So what I'm going to do is remove all of this right now and instead use this conditional ginger, which says that if the mode is generate, then we are going to use this partial which I have created, which is called generate mode and the latest version. And then end this if. But if the mode is improve, then I'm going to reference a different partial which is called improve mode, and have that latest. So here, based on the value of my mode, which is whatever value I give it, if I say generate is the value here, then it would take generate and only run this, versus if I say improve is the value here, it would only run this. And that's where this becomes truly useful to do some of this conditioning prompt management as well. So let me quickly publish this version. I'll say I added partials and conditional usage, and publish this version as well. So you can see that over time I can manage how my versions work and how they would be used. I can also check what is my partial for generation versus for improving, and all of these partials are accessible from the section that we talked about earlier. Now, a few other things that I do want to call out that we are not using in this case but could be very helpful. You could attach your prompt tools or functions that your prompt has access to. You could play around with things like your temperature, max tokens, top P, etc. You could also define what your response format is. For example, if you are going to always work with structured output, you can define that here. Lots of different details within your prompt playground while you're saving your version, and you could also be deploying from here, where we will talk about this in a different video. The last piece that I want to talk about before we end this cookbook is how do you manage your conversation history. For example, I'm going to quickly go to a data set I created for this prompt. This is a set of different inputs that I want to test it against, and we can do this at scale and run reports. But what you can do here is not just have what is the input and which is the mode, but also if there is certain history. For example, in improve mode, maybe you asked for a particular JavaScript function to be written to generate the random hex color. Based on that, there was some response from your assistant, and then you want to, based on this history, now check for an improving input around refactoring. So you can put your entire conversation history as an array here. Here it's just 2 messages. You could define what that looks like. And this history column is of type conversation history. So we always use it when you actually choose to test your prompt. So if I was to go back into my prompt here and I choose to now test this particular version of the prompt against the data set that I just showed you, for now I'm not going to choose any evaluation because our main purpose is to look at how this works for conversation history. I'm just going to trigger this test run and see that for these inputs you can see there's a history being taken in this case. One of them is completed, the others are running. And what would happen here is for this particular entry, it would not just hit this input but append this history as well. So we can go deeper into this case and see that the actual messages that was sent was the system message, then there was a particular user message of the hex code, the assistant, all of this was in the history that we sent, after which this was appended. So this helps you check for scenarios where you have history. You could add history in your data set, you could test this across a variety of scenarios. And of course you get all of the other metrics around latency. If we had added evaluators, you could add them from here and look at your reports. In the interest of time, I'll quickly show you some existing reports that we have also run with evaluations and comparisons between versions. A lot of this is already covered in our other cookbook around comparison and end-to-end evaluation workflows. Here you can see that the scribing agent v7 versus v8 shows you a report of how these versions are doing across evaluations, across cost, tokens, latency, etc. So this gives you an idea of how your prompt engineering could flow into your evaluation pipeline, and some of this continues to become an iterative process over time. Going back to our original coding agent demo so that we have an idea of what this report looks like. You can also share this report with your other stakeholders, look at how this is working over time, and continue to make your prompt engineering changes. So this is a little bit of an overview on the prompt engineering piece. Happy to answer any questions that you may have on using partials, Jinja logic inside your prompts, or the pieces that we haven't covered around deployments, etc. that will be coming in upcoming videos.